There, I got it.
Let me see.
That is the Orion Nebula.
Wow, that's cool. Stars are being born there.
Let's Explore Astronomy is sponsored in part by One of the coolest things to look at through your telescope is a nebula. A nebula is a concentration of gases and dust in space. There are basically two main groups of nebula: diffuse or gaseous nebula and planetary nebula.
A diffuse nebula is the birthplace of a star. When you look at a diffuse nebula, you're looking at stars being born.
A planetary nebula is the remains of a star in the final stages of life, expelling its gases off into space before it dies. We are looking at one of the most famous nebula and one of the easiest to find in the night sky. M42 is the Orion Nebula.
Find the constellation Orion in the night sky. Orion is visible in the northern hemisphere in winter. It is easy to find with 3 bright stars in a line. Those stars make up Orion's belt.
Just below his belt, you will see a small smudge. You can see it with your naked eye. That is where you need to aim your telescope.
The Orion Nebula is 1,600 light years away from us. It is a diffuse nebula, meaning stars are being born there. Some of the stars have already been formed and are only a few million years old. Mere babies! Other stars are still being formed inside it.
Clouds of dust and gas are found throughout the galaxy. As the dust and gases move about, they become turbulent and can concentrate in areas. At this point, the gas and dust can gain enough mass to collapse under its own gravity and form a giant ball of gas.
We call this a protostar. Not quite yet a star, but becoming one.
As the cloud continues to collapse, the hot core starts to gather more and more dust and gas. Thermonuclear reactions now start to take place from the intense gravity causing the massive collisions of hydrogen molecules. Soon the star comes to life and begins to emit light and heat. Eventually, a star is born.
But not all the dust and gas gets made into a star. Some of it starts to combine in areas around the star, and this dust and gas becomes planets.
Some of the gas and dust also form asteroids and comets.
Now you have a solar system, just like ours.
Sometimes 2 or more stars form at the same time, and we have a binary or a multiple star system.
Imagine having 2 suns in the sky every single day.
It takes about 50 million years for an average-sized star like our Sun to form from a bunch of gas and dust into a full-fledged star. Then the star will live for about 10 billion years.
When you look at the stars in the night sky, they all appear white at first. But look closer. With binoculars or a telescope, you will see they vary in color. Some actually appear bluish and some reddish. The color is a clue to the temperature, size, and age of the star.
An easy way of thinking about this is that since the stars are actually exploding balls of gas, you can say we are seeing the flames of the explosions. And as a flame gets to a certain temperature, it turns color. If you look at a candle flame, for instance, it appears yellow and orange. But look at a flame from a blowtorch, and it looks blue because it is much hotter. A common misconception is that the red hot flame is the hottest, but in reality, red flames are the coolest, and blue flames are the hottest. We can now apply that knowledge to stars. If they appear blue, they must be very hot. If they appear red, they must be cooler. And if they appear yellow or orange, then they are in between or of a medium heat.
Our sun is an average star, so it looks yellow or orange. There are many stars like our sun. For example, Tau Ceti is about the same as our sun, and recently they discovered 5 planets around it. One planet is the right distance from Tau Ceti, like the Earth is from our sun. It could be Earth-like and maybe, just maybe, possibly have life on it.
Red dwarfs are the smallest stars, and may be only about 10% the size of our sun. Since they are red in color, they are also cooler in temperature. All this means they also do not burn their fuel as fast as other stars. So red dwarf stars can live tens of billions of years.
Blue stars are just the opposite. They are huge and hot. They could be 100 times bigger than our sun. But because they burn so hot, they may only live for a few million years instead of billions of years like other stars. While you are looking at the Orion Nebula, you can easily find a blue giant star. The star is a foot of Orion and is called Rigel. Rigel is 70 times bigger than our sun and 40,000 times brighter. I think that Rigel is also where Herc comes from.
Ha ha ha, I heard that.
This huge star up in Orion's shoulder is Betelgeuse. It is red, but it is also huge. Wait a minute, back up here, people. Wait a minute, something's wrong here. Why? Red stars are supposed to be small, not huge.
When most all of the hydrogen in a star has turned into helium, there can no longer be any thermonuclear reactions. The star begins to cool down and die. But before it does, as it is dying, it starts to grow bigger and bigger, becoming what we call a red giant. As the red giant's gases are expelled into space, the star's core that remains is called a white dwarf. Soon all the hydrogen is gone and used up. Now there are no reactions in the star at all. It cools way down and is dead. We call it a black dwarf. This is the fate of all average stars like our sun.
But bigger stars do not shrink back to a black dwarf. They go out with a bang, literally.
As a blue giant's hydrogen gets used up, it starts to cool down and expand. As it cools, it goes from a blue color to red, turning into a red giant. But the star is so big, it cannot support its own mass, and the core shrinks to only a dozen miles across. The star explodes in one hugely massive cosmic explosion called a supernova.
What is left is a giant cloud of gas and dust, a nebula. But this type of nebula is the second type we mentioned, a planetary nebula. This is a planetary nebula, NGC 6543, the Cat's Eye Nebula.
Even though it is called a planetary nebula, it has nothing to do with planets. A planetary nebula is the dust and gases expelled from a dying star. This is M13, the Ring Nebula.
And this is M1, the Crab Nebula, also a planetary nebula.
Sometimes a neutron star forms from the remains of the original star after a supernova. In a neutron star, all the atoms are crushed completely. The electrons are jammed inside the protons. This makes a star completely made of neutrons. It is very tiny and maybe only 20 kilometers across.
If the original star was big enough, a black hole may form instead. A black hole is so dense with extreme gravity that nothing can escape it, not even light.
Throughout the universe, stars are being born and stars are dying. Through the wonders of astronomy, we can watch it all happen and learn from it, viewing these wonderful and beautiful nebulae. In about 5 billion years from now, even our sun will grow into a red giant and expand all the way out past Earth, then collapse down to a white dwarf, leaving a planetary nebula of gases and dust that will flow out into space. In future episodes, we will get deeper into neutron stars, black holes, pulsars, and quasars. A future episode of Andromeda Timeslip will take a closer look at supernovas, so be sure to tune in. Now, Velocity and I will get back to exploring the night sky, and you can too. Happy stargazing! Okay, it's my turn now. What you looking at?
check out our other episodes in Let's Explore Astronomy series at www.tedcookproductions.com/LEA.
You will find all kinds of cool astronomy topics there. Hey, give a shout out to our sponsors, without whom we would not be here. Visit their websites and partake of their services and products. A big thank you to the Yukon Department of Tourism and Culture and Westmark Hotels, Westmark Whitehorse.